Okay, so looking at your problem here, you already found f of 0 and f of 11. They found what those equal. And that's important because they're saying what they want us to find is the, let me verify. I think they want you to find the maximum. There we go. They want the absolute min and absolute max. So you already found these numbers. Now, why those are important is because they say they want us to find the maximal flow rate or minimal flow rate of a river in the first 11 hours. So now we have hour 0, hour 11, and because this thing is just a polynomial, we know it has to be a nice smooth curve that looks something like this. So therefore, just depending where our cutoff is, where the axes are located, we could either be there, or anyway. So we'll figure it out. So the other thing we need to find is where is that local relative minimum and where is that relative maximum. And once we find those, we will see if those are bigger or less than our f of 0 and whatnot. So this brings us back to, I think, section 4.2, where we say, how do you find relative mins and maxes? Well, we are not going to do it in our calculator anymore. We are doing derivatives. So that being said, we're going to use our calculator, haha, when we do the derivative here, just to help us out. What's 3 times this and 2 times that? And we'll run through our derivatives here. So once you do that, you end up with the following derivative. And so now, how do you find where this thing equals a max or a min? Well, we know all of our slopes, whenever we're at a max or a min, the slope of the tangent line is always equal to 0. So therefore, what we're going to do here is say, where does this thing equal 0? So now, how do we solve this? Well, now at this point, this thing is just a, whoops, I apologize, this is an X, it's supposed to be an H. So now that we have this, it's just a quadratic. So if it factors, probably not going to factor with all these decimals, but you could give it a shot if you want to multiply everything through. Or probably the easiest way to go about it is just go quadratic formula, negative b plus or minus square root of b squared minus 4ac all over 2a. Then once you have that, you'll take those two values and you'll find f of whatever this value may be. So f of, there's going to be 2 of them, so h sub 1 and f of h sub 2, find out what those are, and then time to compare and contrast. Which one has the largest flow? Which one has the largest number? Which one has the smallest number? And remember, we're substituting this back into the original, not the derivative, back into the original equation, because we want to know the flow, not the rate of change, just the flow. So we substitute those back in, we get these numbers, we compare those two numbers and these two numbers that you already found, and we see which one has the most, which one has the smallest, and that will give us our min and max. Hope that helps.